Hi, I'm Michael, and I will be talking about data analytics. Before I start, though, have some time to enjoy some memes related to this topic. So, after looking at those memes and the agenda, you are probably dying to hear what data analytics is all about. Well, today is your lucky day because I'm going to tell you. TechTarget.com defines data analytics as a process of examining data sets in order to draw conclusions about the information they contain, increasingly with the aid of specialized systems and software. There are several different applications that the term data analytics refers to. Some of these applications include, but are not limited to, business intelligence, online analytical processing, and several other forms of advanced analytics. You can compare data analytics to business analytics, although data analytics has a much broader focus. There are two main methodologies to data analytics. They are exploratory data analysis and confirmatory data analysis. Statistician John W. Tukey wrote in his book Exploratory Data Analysis that EDA is similar to detective work, while CDA is similar to the work of the judge or jury during a court trial. Furthermore, data analytics can be separated into quantitative data analysis and qualitative data analysis. The quantitative data analysis approach focuses on analysis of numerical data with quantifiable variables that can be measured statistically, while the qualitative approach focuses on understanding the context of non-numerical data such as text, pictures, audio, and video. This can include common phrases, themes, and points of view. As you can imagine, there are several different uses for data analytics. Business intelligence, or BI, is equipped to provide business executives and other people high up in the organization with solid information regarding key performance indicators, business operations, and customers, among other things. Key performance indicators, which I just mentioned, are defined by TechTarget.com as business metrics used by corporate executives and other managers to track and analyze factors deemed crucial to the success of an organization. An effective KPI will focus on the business processes and functions that management of an organization sees as most important for measuring progress. Another common use of data analytics that many of you may have heard of is data mining. TechTarget defines this as the process of sorting through large data sets to identify patterns and establish relationships to solve problems through data analysis. Data mining is used in all sorts of different areas such as mathematics, cybernetics, marketing, and genetics. Data mining is a means to drive efficiencies and predict customer behavior, and if used correctly, a business will be able to set itself apart from its competitors by using predictive analysis. One particular type of data mining is web mining. This is typically used in customer relationship management. Web mining integrates information gathered by traditional data mining methods and techniques over the web. The goal of this process is to understand customer behavior and evaluate the effectiveness of a certain website. Some of the other techniques for data mining include, but are not limited to, network approaches for classifying patterns, ensuring proper execution of data mining algorithms, mining large databases, the handling of relational and complex data types, and machine learning. Another major use of data analytics is predictive analytics. TechTarget defines this as a form of advanced analytics that uses both new and historical data to forecast future activity, behavior, and trends. This process involves applying statistical analysis techniques, analytical queries, and automated machine learning algorithms to data sets in order to make predictive models that are able to assign a numerical value on the probability of an event happening. In order to use predictive analytics, a software application uses special variables that one can measure and analyze in order to make a prediction about the likely behavior of certain entities, such as a person or a machine. TechTarget gives the example of an auto insurance company looking at many different variables like age, gender, location, vehicle type, and driving record before setting one of their policies. To create a predictive model, multiple variables are combined. When this happens, the model becomes capable of predicting the probability of future events with sufficient accuracy. In order to make this process work, the predictive model needs sophisticated algorithms and methodologies like logistic regressions, time series analysis, and decision trees. The, the popularity of predictive analytics has grown with the emergence of big data, as big data has given organizations more opportunities to use this process. Marketing, financial services, and insurance companies are some of the areas that predictive analytics is used most in. The next use or rather form is big data analytics. According to TechTarget, this process of examining large and varied data sets to uncover hidden patterns, unknown correlations, market trends, customer preferences, and other useful information that can help organizations make more informed business decisions. Big data analytics applications make it possible for data scientists and other people in similar positions to analyze huge volumes of structured transactional data and other forms of data that are typically untapped by your typical business intelligence applications. Finally, the last form of data analytics that will be covered is text mining. Text mining is defined by TechTarget as the analysis of data contained in natural language text. With text mining, an organization will be able to derive valuable business insights from text-based materials such as Word documents, emails, and social media posts. One of the challenges to this process is mining unstructured data because natural text language tends to be inconsistent. Of course, the data analytics process is more than just analyzing data. For these applications to work, there must be more work done up front. The upfront work includes collecting, integrating, and preparing data before developing, testing, and revising the analytical models to make sure that they produce accurate results. In many cases, data engineers are hired by analytics teams to make data sets ready for analysis. The first step of this process is data collection. In this step, data scientists decide the information that they will need for a particular analytics application and then work on their own or alongside data engineers and other IT guys to build it. The next step to the process is finding and addressing problems that could affect the accuracy of the analytics applications. This step involves data profiling and data cleansing jobs in order to ensure that the data is consistent and that errors and duplicate entries are eliminated. Finally, the actual data analytics part of the process begins. In this step, a data scientist will build an analytical model. He will do this using predictive modeling tools or other software and programming languages like Python, Scala, R, and SQL. This model is then run against a partial data set in order to test the accuracy. The model is then revised and tested again until it works as intended. When we get to this point, the model is run in production mode against the full data set. This is the final step to the data analytics process, but it can be repeated. In conclusion, data analytics is a process of examining data sets in order to draw conclusions about the information they contain, increasingly with the aid of specialized systems and software. Data analytics contains two main methodologies, EDA and CDA, as well as many forms and uses. Lastly, for data analytics to work, data scientists must run through the data analytics process. Thank you for watching this presentation.